Hi class. So we had just a couple of examples, but to get through to finish up chapter 4 that we didn't get through today. So as promised, I said I would make a short video here, probably about, I don't know, 5-10 minutes, just to wrap up this chapter. You can watch this instead of having class tomorrow since there's a 2-hour delay. So we left off on example 6, and with example 6, we're kind of rushed. I want to slow down and go through this a little more clearly for you. Sorry about the rush. I was trying to get through. We're given some data of number of years after 1949 and what the world population in billions are, and we're using this to kind of make a model to see what might be better, linear model, exponential model, for predicting the world population. So I mentioned before that you won't have to be able to build the model, but just so you know where we're coming from, because you can also build a scatter plot, graph a scatter plot with your graphing calculator. So if you go to the stat menu and then go to edit, then this is where you can enter in the list. So you can treat like L1 as X and L2 as Y. So I can enter in my X values from the chart, so 111, 21, 31, 41, 51, and 61, etc. And then in L2 I can enter in the Y, so we have what, 2.6, 3.0, 3.7, so forth, 5.3, 6.1, and lastly 6.9. Alright, so let me just double check, make sure I didn't make a mistake here. So 111, 21, 2, 6, 3. Right, so I don't think I made an error. Right, so then to get these, so these two printouts from in the notes, these are like the linear regression line and the exponential regression line. These are the outputs that the calculator gives us. So in order to get to that, you're going to go to second, and then we want to go to, wait, excuse me, I think you just hit stat and then go over to calc, my bad. So if you're from like on this screen, you're just going to hit stat and then go over to calculate, and then you can see there's a line regular, option 4. That's how you can get that line. If you hit enter, it'll give you those inputs. If you notice, it doesn't give you the r and r squared value. If you want that, you only have to do this one time, and by default it's turned off, is you have to do what's called turn your diagnostics on. So if you go to second and then hit 0, which is catalog, then you have to scroll down till you get to the D's and look for diagnostic on here, and then hit enter again, and now it'll be turned on. So then when you go to stat and then calculate and then option 4, the line regular, now it will give you the r squared and the r values appropriately, right? So that's just a screenshot of this. And then to get the other one, you go to stat, calculate, and then we have to go down to the exponential regular, so option 0, and then that will generate that screenshot, right? So then we filled in these equations, right? So let me write this down just in case you missed this. Let me get some ink here. Right, so part A we should have had for the linear regression, f of x equals 0.074x plus 2.294, and then for the exponential, we should have had g of x equals 2.577 times 1.017 raised to the x power, right? So these are two appropriate models. So f of x and g of x are the world population in billions, and then x here in this case are the number of years after 1949, right? So same units. So then part B of this question is asking us, how well do the functions model world population in 2000? So we talked about how, for the year 2000, that means we have an x value of 51, right? And that can be found by taking 2000 minus 1949, right? So there's 51 years after 1949 to get to the year 2000. So then we want to find f of 51 and g of 51. So if you plug those in your calculator, you should get 6.119, and for g of 51, you should get 6.041. Right, and the actual from the table is listed here, right, which is 6.1, which both of these are about 6.1. So both are a good fit. Right, they both predict pretty closely to the actual. So then part C is we're told by one projection the world population is expected to reach 8 million in 2026, right? So supposed to have 20 in 2026, supposed to have a population of 8 million or 8 billion, right? So what we're asked to do is find which function serves as a better model for this prediction, right? So if we take 2026 minus 1949, we get 77. So what we need to do is find what's f of 77 and what's g of 77, and see if one or both of these are going to be close to 8, right? So f of 77, right, would give you 7.992, and g of 77 gives you 9.364, roughly, right? So this one is closer, right? This is approximately 8 billion, so the linear model it does a better job, right? So the answer to part C is we would say the linear model f of x, right? That does a better job with that prediction. The exponential model is overestimating by about 1.3 billion, which is quite large, right? All right, so hopefully that example makes more sense now. So now the last example, the last type of problem that we want to look at is being able to express something in the form y equals a times b to the x, but represent it in base e, right? So this is kind of the idea, is if you have y equals a b raised to the x power, that's the same thing as if I have y equals a to the e and then natural log of b times x, right? Because those of course will even itself out, right? E raised to the natural log of b is just equal to b, right? That's why they're equivalent. So when I have, so if I look at this example, what we're trying to do is take this equation that we got last time, and rewrite it, but with the power of e, right? So I can rewrite this as g of x equals 2.577 e raised to the natural log of 1.017, and this would be times x, right? So now what I can do is take the natural log of 1.017 and get an approximation of this, right? So if I pull over my graphing calculator, do the natural log of 1.017. So you can see if we round to 3 decimal spots, we get about 0.017. Right? So that means that g of x is equal to 2.577, and then e raised to the 0.017x. Right? So that's the answer. But if you notice here, I don't want you to get a misconception that I just subtract 1 away to get from here to here, because that's not true. This is just a coincidence that happens to work out. Right? So I came up with another example to help with this. So let's say you have the equation y equals 4 times 7.8 raised to the x, and we want to rewrite in terms of base e, right, just like before. So this means that y equals 4 raised to the e natural log of 7.8 times x, right? So just following that equation at the top, right, trying to rewrite this. Then if we look at, simplifying, what's the natural log of 7.8? Let's get an approximation. That way we can plug that in. We can do that. So the natural log of 7.8 is roughly 2.054, so we'll go to 3 decimal spots. So I can plug that in and get y equals 4 times e raised to the 2.054 times x. All right, so these two equations are just rewritten with a different base. Right? All right, so I think that's all for chapter 4. So don't forget that all the upcoming announcements and things, and good luck studying for your tests and on your tests. Be sure to email me if you have any questions. Thanks.